We learned about beta VAE, and when we're going through that topic, we compared it to InfoGAN, and I promise that I'm going to go through InfoGAN. The video is online. You can watch it for more details. As for the big picture, what you want to do is to disentangle information in your hidden space. So for GANs, you usually have a latent variable. That latent variable, you sample it from a normal distribution or a uniform distribution. You push it through a nonlinear generator or nonlinear neural network. And in the end, you're going to get generated images. And we're doing some cool stuff in the latent space, like doing arithmetic, adding, subtracting in the latent space. But those analyses or those experimentation were based on the entire vector. And that vector was perhaps 100 dimensional. And we couldn't separate one dimension from another dimension and focus on each one separately and associate meaning to them. But here, with InfoGAN, with beta variational autoencoder, you are trying to associate meaning to every component of those vectors, or at least some portions of them. So let's try to do that. For MNIST, let's say you want to generate images that look like MNIST. Let's define a latent variable C1, which is categorical, and then two latent variables that are uniform. One of them is going to correspond to different digits. The other ones are going to correspond to different length or rotation. Now you can clearly see that one of them has the rotation meaning, the other one has the width meaning, and the other one corresponds to integers. How do you do it? The idea is to create disentangled representations. And disentanglement is not only about handwriting rotation, the width of your handwriting, the digit itself. It could be any one of those, like disentangling pose from lighting. And why is that useful? Because then you can keep the pose, change the lighting, and get different images. Or you can keep the background digit, but then make it rotated or make it wider. Or you can change the hairstyle, or you can put eyeglasses on people by changing only one of these components of your representation. This is the loss of a regular GAN. For InfoGAN, you are trying to preserve the information in your C vector. You take C, you take Z, you push them through a generator that's going to generate some images. You are going to compare the information components or the information content of G and C. And you want your model to preserve that information. You don't want that information to go away. And for mutual information, think of it in the extreme sense. If you have a random variable that is independent from another random variable, any information that you have on random variable y is not going to reduce the entropy of variable x. It's not going to help it in any fashion. It means that entropy of x given y is going to end up being entropy of x. So that one is just going to end up being 0. But the more information you have in y about x, the information content is going to go higher and higher. And that's exactly what you're trying to do here. But like variational autoencoders, where you were trying to maximize your marginal likelihood, and you wouldn't be able to write down your exact formulation of your marginal likelihood, it's the same story here. You are not going to be able to write down the exact formulation of this information or mutual information. Why is that? Because it's going to depend on some posterior. So you need to know your posterior, which is intractable. But we know the methodology. We saw it when we were doing variational autoencoders. We're going to see it again here. Whenever you don't know your posterior, approximate it. And then write down a lower bound for the quantity of interest or an upper bound for your quantity of interest. And then if you're trying to maximize the information content, you're going to maximize the lower bound. And then as a result, you're maximizing the information content because that's a lower bound. This auxiliary distribution is a variational distribution. It's going to have its own parameters. There's going to be a neural network here. Then you're going to optimize that. Not only you're going to optimize your generator, Not only you're going to optimize your discriminator, you're going to optimize your approximate distribution. And once everything is done, you can disentangle information. Any component of your C, if you pick it and change it, you can associate a meaning to it. For instance, perhaps the first component is about rotation, the second component is about the width of your chairs, or they could be about hairstyle or emotion. Any questions about InfoGAN? Was everything clear? Okay, awesome.